Hey everyone, my dear student, let's start our class. Well, we're gonna start our next chapter, that is current, electricity, chapter number 3. So chapter number 3, current, electricity. Okay, so write down current, electricity. So far we have done in our previous chapter we know that charge at rest, or the charge cannot move, isn't it? Static, isn't it? So today onwards we have charge at motion. Okay, so let me glance the chapter. Today we'll only talk about the introduction, right? So write down definition of current. Okay, so it is defined as the rate of flow of charge, isn't it? The rate of flow of charge. You know this one, it's a flashback of class 10, isn't it? Flashback or recap. So today we'll recap, or why we're recapping this, why we flashback, because we need this one, isn't it, for further topics, to deal with further coming topic. So current, current is defined as rate of flow of charge, or you can write this as net charge. Right. So you know that rate means the time, isn't it? Rate means the time. So write down mathematically current equals to how much? Rate means the time. Denominator ma ke lekhnu parcha? Time. Kusko charge, isn't it? So this is our current, rate of flow of charge. Right. So now see, the unit of current is what? So the unit of charge, coulomb, time, second, so per second. We cannot we have new unit of current. Okay, so SI unit of current is what? Ampere, or denoted by E. Clear? So now next step, where it flows. Current is flow, isn't it? Flow of charge. So where this charge flows? Inside a conductor, isn't it? So we know that conductor, isn't it? In our previous lesson we know that conductor, isn't it? Yes. So which has obviously it has electron, and we call it free electrons. Right. So many atoms are there in a conductor, and which got free electron, isn't it? So they are moving, isn't it? Randomly, isn't it? Randomly they were moving. At this state we cannot call the current is passing. Okay, charges are moving, electrons are moving, but still current is not there, isn't it? Why? Because current is rate of flow of charge. Clear? So when there is a net flow, see, because this is uniform, isn't it? The system is uniform at equilibrium pani bhancha, okay, in your chemistry. So when this charge or net flow occurs, okay, so at that time when it occurs, So you have to see नेपालीमा भन्नु पर्दा करेन्ट कति बेला फ्लो गर्छ भन्दा नि see example you know that lockdown is there, isn't it? So if you go Rani pool randomly like this, can your policeman tolerate? No. So they will lathi charge, isn't it? हिर्काउँछ पठाउँदैन source, isn't it? Drift, isn't it? That is the flow, isn't it? Drift or drag you to your home, isn't it? Or they will send you to your home, respective home. So randomly you cannot go. So to get, we have police, isn't it? So that is your, you have to apply electric field. So this is the electric field. So you know, obviously the electron moves this direction, isn't it? Yes or no? Opposite of electric field, the direction of electrons, right? So it will move, isn't it? Right. So but you know that atom consists of other protons are there, isn't it? Protons. So electron, free electron, outermost electron is your free electrons, and it forms ions, isn't it? इलेक्ट्रोन त बाहिर छ, सो आयन्स त स्टेबल हो नि त, एटम त स्टेबल बस्नु पर्यो, नभए तिम्रो यो पनि चल्नु पर्यो नि, isn't it? Right. So this, without an electron, after applying this pulleys or electric field, these are called, ions are called kernels. Okay. So so many kernels forms, isn't it? Right. So whenever you apply electric field, this has to cross this and this, so obstacles are there, isn't it? And this obstacle, it has to collide, isn't it? So that collision is called resistance. New topic, पढेको छ 10 मा पनि. ओके, you know resistance. Resistance के को कारणले हुन्छ? Due to collision between what? Kernels and electron whenever you apply the electric field. Clear up to here? So now write down cause of current. Cause of current is due to electric field. Otherwise electron moves randomly and it creates the uniform environment inside the conductor. So whenever you put electric field, then only it will produce current. Clear? Like pulleys. And resistance is due to collision of electron and kernels. Okay, ions. Electron त बाहिर निस्किन्छ एटमबाट. सो थुप्रो छ कि छैन एटम, अरु रहेको आयन्स भन्छ त्यसलाई हैन. सो त्यो आयन्सलाई के भन्छ यहाँनिर अब? कर्नेल्स. ओके. सो यो इलेक्ट्रोन जाँदाखेरि के हुन्छ? बाटोमा ठोकिन्छ, isn't it? सो त्यसकारणले गर्दाखेरि त्यो ठोकिनुलाई नै के भन्छ? रेजिस्टेन्स, which is opposition to the flow of current. अब यो त ड्र्याग भएर सिधै जानु पर्यो नि हैन, तर के हुन्छ? बीचमा ठोकिन्छ. So that is your resistance. Hope you understood, and this is just a what do you call, flashback of class 10. So next, you know that Ohm's law, isn't it? Ohm's law, isn't it? Class ma मैले Ohm's law सोध्यो, तिम्रो nobody will define it correctly. Okay, and तिमीले define गर्न सक्यौ भने you cannot tell me the correct dependence. Okay, so Ohm's law, validation of Ohm's law, write down how it varies. Okay, when the physical conditions are constant. Okay, so this is our Ohm's law. I is directly proportional to V. Ohm's law, right? Or some may write B equal directly proportional I R. So don't confuse this. This means same, but here meanings are different. Okay, right? So don't bother with this, just write V equals to IR. This is our Ohm's law, right? So Ohm's law to be valid, then this must be constant, right? Why? Because constant of proportionality, isn't it? Why? Kina? Because if you have a conductor and if you increase the temperature, then collision also increase. You know that boiling of water, isn't it? If you increase the temperature, the molecule start moving, right, randomly, and it collides each other. So if you increase the temperature, then the collision increase, so resistance increase. So that means this is not valid. Clear? So if this remains constant, then only Ohm's law valid. Clear? So validation of this one, write down physical condition. Okay, at Ohm's law is valid at constant physical condition. Okay, so those are the temperature, resistance. Okay, right? So next we'll talk about this resistance. Okay, little bit about resistance. So you know that resistance is due to collision of electron and kernels, right? So resistance is due to collision between electron and the other atoms, or you may say the kernels. Clear? So now in our class dependence of R, we have to talk about dependence of R, where it depends. Okay, so if I take this as a conductor, so this is cross section area and this is the length of the conductor. Clear? So R is directly proportional with the length, because जति लामो बाटो छ त्यति ठोकिन जानु परेको पर्यो नि इलेक्ट्रोन, पाथ भन्ने कुरा आउँछ। ओके, जति लामो बाटो छ त्यति इलेक्ट्रोन कोसँग ठोकिन्छ, एटमसँग। सो लेन्थ इन्क्रिज, रेजिस्टेन्स इन्क्रिज। अगेन अब बाटो चाहिँ कहाँको हो, इज इट राइट? बाटो चाहिँ कहाँको? सो ए इज योर बाटो चाहिँ कहाँको, इज इट? जस्तो अहिले बस्तीमा यस नान्डोकतिर गयो भने के हुन्छ, मान्छे कम्ती भेट्छ भेट्दैन, त्यो कोलिजन कम्ती हुन्छ। बजारतिर अलिक बेसी छ मान्छे, सो कोलिजन बेसी हुन्छ। सो दिस डिपेन्ड्स अन द लेन्थ अफ द रोड। ओके, कहाँको बाटो? सिई। सो तिम्रो यो ठुलो छ भने, बाटो ठुलो छ भने के हुन्छ, you cannot collide frequently. Okay, so again we introduce another constant, that is rho, L by A, and this is also a resistivity. Okay, अघि मैले भने this is nothing but the कहाँको बाटो। ओके, बस्तीको गयो भने के हुन्छ, अहिले त लकडाउन छ, तो ठोकिँदैन, सो रेजिस्टेन्स कम्ती हुन्छ। क्लियर? सो दिस डिपेन्ड्स अन मेटेरियल अल्सो। ओके, रेजिस्टिभिटी इज ए क्यारेक्टर अफ मेटेरियल भनिदिएको छु मैले क्लासमा। ओके, एन्ड विच मेटेरियल अल्सो। ओके, सो नाउ लेट्स स्टार्ट द डेफिनेसन अफ रेजिस्टिभिटी। रेजिस्टिभिटी के हो, विल तिमीले बिर्स्यो अरे। ओके, रेजिस्टेन्स भनेको के हो, opposition of flow of current, isn't it? Or it's a obstruction between the path of the current. So resistivity, you don't know, isn't it? I don't know also, but see, this is your formula. Physics, you know the formula, then you can derive the definition of resistivity. See, what is this? Rho, take over here. What is this? unit of resistance, that is your ohm, isn't it? Yes or no? Yes. So rho, if I take this as meter square, clear, this as meter and area as meter square, then see, new resistance R dash equals to how much? What is this? Meter per, what is this? Meter square. Rho is there, isn't it? So rho is equal to how much? R dash meter square by meter. Understood this much? See, if I take this as unit, this as unit, then R dash equals to how much? R dash equals to, if I take this as unit 1 meter and this as 1 meter square, so how much I'll get? Resistivity equals to how much? See, this is 1, sorry, R, and this is 1, this is 1 square, so this equals to rho. So definition of resistivity is what? It is a resistance, isn't it? It is a resistance per unit volume, per unit volume. So resistivity is nothing but it is a resistance per unit volume, clear? So that means you can find the what you call unit, isn't it? So meter cancel, rho equals to how much? Unit of resistivity. So this is your ohm meter. SI unit of resistivity is your ohm meter, clear? If you didn't got, then we'll talk about it, isn't it? So many questions we have done in class 10, that is rho R dash. Okay, so have a glance. Okay, so now next we have Ohm's law is there, isn't it? Right, Ohm's law. So Ohm's law, V equals to I R. Look at this formula. V is scalar, R is also scalar. I, what is I? We also talk about, we have done with I, isn't it? This has direction and magnitude also, but still current is not a vector quantity. Current is not a vector quantity, it's a tensor quantity. Okay, tensor quantity, clear? So up to here you understood, isn't it? So that why current is not a vector quantity, because see, you know this one, isn't it? Your wiring in your house. So if I say 2 ampere, then this is also a 2 ampere. So but our vector addition law, if you apply, then this won't be this, isn't it? If you add this to, you won't get this much. So current does not follow the vector addition of triangular law. Okay, remember this one, it does not follow the vector addition. Okay, so if I want to get the vector form of this Ohm's law, what would be that? What you will get? So well, so write down vector form of Ohm's law. and this is also called microscopic form. Okay, micro, some entrance exam, scopic form, microscopic form. Vector form of Ohm's law is also called microscopic form. Okay, so you know this one, V equals to IR, isn't it? V equals to IR. Again you take, this is a conductor, and this is E, cross section area, L is the length of a conductor. Then we applied E, isn't it? Yes or no? E. What is V over here? V equals to ER. We know this one in our previous class. V equals to ER. So here in place of R, what we have? EL, isn't it? Yes or no? So V equals to what then? EL equals to I as it is into R, rho L by A, isn't it? In place of R we can write rho L by A. So L cancel, left how much? Left how much? E equals to rho I by A. This is current per unit area. What is that? That is your current density. We call it current density. This is what? Current per unit area. This is current density, and we denote by Z. Clear? We denote by Z. So E is your vector, so rho Z, current density is also a vector. Clear? So this is your current density, so Z equals to how much? E by rho. So which implies J, that is current density, 1 by rho E. So this is our vector form, okay, of current density. Clear? So this is 1 by this, look at this, this is 1 by rho, we call it conductivity. Okay, conductivity, and we denoted it by sigma. So some student may say so many symbols are there. This is volume charge, right? Density. This is your surface charge density, isn't it? So don't confuse in exam. They may write this, then they open the bracket and denote it, whether it is a surface charge density or a conductivity. Okay, in chemistry also. So this becomes J equals to rho E. So this is our vector form of Ohm's law. Clear? I hope you understood. If you don't, then pause the video, then do again, right? So simple is there. So from next class we have derivation and all. So have a good day. Thank you.